this CME, and today's CME we are going to talk about inflammation. Basically, we are going to do acute inflammation. In the subsequent videos, we'll be looking at chronic inflammation. So we want to start by defining the word inflammation. So basically, what we mean when we say inflammation is a type of tissue damage that is caused by physical trauma or is caused by infectious organism that brings about vascular and cellular events to bring about clearance of the infectious organism or the damaged tissue. So we can recap. We say that inflammation refers to a type of tissue damage that is caused by infectious organism or physical trauma. It can be a hit that brings about vascular and cellular events that brings again subsequent clearance of the infectious organism or the damaged tissue. So first of all, we are going to look at the cardinal signs of acute inflammation. There are cardinal signs of acute inflammation. So we want to outline them here and we go stepwise to see each other. So one of the cardinal signs is swelling, also known as edema. The second cardinal sign is redness. The third cardinal sign is warm. The fourth cardinal sign is pain. And we can also have another one, loss of function. Call it as loss of function. So we'll be going stepwise and looking at how all these physical signs come to present. So let's start by looking at, we have an infectious organism. Let's say that it's a gram-positive bacteria. So this bacteria here produces endotoxins. So once this bacteria produces endotoxins, the endotoxins damages the tissues around them. These endotoxins damages the tissue around them. The same endotoxins from the bacteria also, remember there is certain animal here, so let us have a look at this animal. This is referred as a mast cell. It's known as the mast cell. So the same endotoxins bind to mast cell receptors. Once they bind to mast cell receptors, they activate the mast cell. So a series of degranulation takes place here. So let us have a look. When mast cells are activated, degranulation takes place. There are some substances which are emitted, which are produced by the mast cell. So let us look at the substances. Substance number one, we have histamine. Substance number one is histamine. Substance number two is prostaglandins. Substance number three, we have leukotrienes. We also have leukotrienes. Okay. Another thing, we have a certain enzyme here. We have a certain enzyme known as phospholipase N2. We will get to know the importance of this enzyme, phospholipase N2. So, phospholipase N2, remember we have the damaged tissue. And the tissues, any membranes we have, they contain phospholipids. They contain phospholipids. So again, let's have a look at the function of phospholipase 2. The tissues are damaged by the endotoxins emitted by the bacteria. The tissues contain phospholipids. Here comes phospholipase A2, act upon the phospholipids. Guess what is going to be produced? So phospholipase 2 act on phospholipids. They convert phospholipids into arachidonic acid. Arachidonic acid. Again, once arachidonic acid is released, it can undergo two pathways. So here we have arachidonic acid. We have said it can undergo how many pathways? Two pathways. So pathway number one, it can be acted by performed by lipooxygenase enzyme to produce several leukotrienes. Pathway number two, it can be acted upon by cyclooxygenase enzyme to produce prostaglandins. Remember, we had prostaglandins. We have leukotrienes produced by the mast cells. Now again, we have the damaged tissues. Damaged tissues containing phospholipids. We have said phospholipase A2 acting upon phospholipids to produce arachidonic acid. Then arachidonic acid undergoes how many pathways? Two pathways. Pathway number one, through the lipooxygenase to produce several leukotrienes. Pathway number two, through the cyclooxygenase to produce prostaglandins. Then again, we also have pain receptors over here, the nociceptors receptors. And then in the vascular tissue, within the vasculature, we have factor 12. It's one of the clotting factors. So factor 12 activates procalcrin, and then procalcrin gets activated to calcrin. Guess what calcrin does? Calcrin does what? Activates kininogen to bradykinin. So here we have factor 12 activate to procalcrin to calcrin, then calcrin does what? Comes act on kininogen and activates them to bradykinin. We get to know the function of bradykinin. Now we have all these factors. We have histamines, we have leukotrienes, we have prostaglandins. Guess all these factors does? These factors come here. These all are endothelial cells. This is the vasculature. It's a blood vessel. This, remember, blood vessel is surrounded by endothelial cells. So these are endothelial cells. This is the vasculature, and we have the plasma over here. So all these factors bind to receptors on the endothelial cells. When these factors bind to endothelial cells, the receptors on the endothelial cells, guess what happens? They contract. So we have the normal endothelial cell. So once these endothelial cells contract, what happens? They tend to reduce in size. So meaning there are gaps over here. So they contract, they contract, they contract, they contract. They are contracting. They are contracting. Thereby they are creating gaps over here. So guess what the consequence of this? We have plasma over here. So plasma tends to leak out through these gaps and now accumulate out. This is what brings about swelling, edema, because fluid, the plasma fluid has leaked out of the vasculature to accumulate in the interstitial space, so thereby causing swelling or edema. So this reduction in size and creation of the gaps, this is what is called vascular permeability. So when all these substances bind to the endothelial cells, then endothelial cells, they tend to increase vascular permeability. The vasculature becomes more permeable. In other words, the plasma contents, the plasma fluid tends to leak out of the vasculature, hence causing swelling and edema. Now we have come to know how edema or swelling comes about. The next thing, we are going to learn about how redness comes about. So the same substances. Remember here the smooth muscles. So the same muscles bind to receptors on the smooth muscles. So when they bind to receptors on the smooth muscle tends to relax. So when the smooth muscle tends to relax, guess what happens? The diameter of the blood vessel does what? Increase. So when the diameter of the blood vessels tends to increase, more blood tends to flow through the vasculature. This brings about the redness. So when the smooth muscles does relax, the vasculature, the size of the vasculature, the diameter increases as a result of relaxation of the smooth muscles. So therefore, more blood flows through the vasculature. Remember that the same blood, when the same blood flows through the vasculature, when more of the blood tends to flow through the vasculature, that's when you touch and there is more inflammation. When you touch over the surface, when the damaged surface or the surface, you are going to feel some warmth. You're going to feel some warmth. Next thing, remember we've said there are pain receptors over here, and we say they are also known as nociceptors or nociceptors. So as the fluid, more of the fluid comes out of the vasculature, tends to compress the pain receptor, tends to compress and put more pressure on the pain receptors. They get more stimulated. Guess what happens? It brings about pain. Brings about pain. Then there are these things we've said about that are called bradykinin. These bradykinin have the tendency of activating these guys have the tendency of activating the pain receptors. And all the net effect of that is pain. We have prostaglandins being released over here. So the same sometimes when you get a knock or in the presence of an infectious organism, sometimes you may get some fevers of the world. And it is because of the prostaglandins that are released. Remember the prostaglandins can be carried up to the hypothalamic centers. Yes? Heat regulatory or temperature regulatory centers, thereby activating, and this brings about what? Fever. And thank you guys. In this video, we'll be talking about acute inflammation. And before we conclude, let's have a recap again before we end up our CME. So we say the presence of a bacteria. The bacteria releases endotoxins. Endotoxins cause kind of a damage to the tissues. The same endotoxins bind to one cell receptors, activate them, a kind of degranulation takes place, release of histamines, prostaglandins, and glucotrips. The same damaged tissue. We have the enzyme phospholipase A2. The enzyme phospholipase A2 act on phospholipids. Phospholipids converted to arachidonic acid, Arachidonic acid undergoes how many pathways? Two pathways. One pathway acted upon by lipoxygenase, releasing some different leukotrienes. The second pathway acted upon by cyclooxygenase, producing different prostaglandins. We also said we have pain receptors over here, the nociceptors. We also talked about the factor 12, clotting factor, being activated to pro-kallikrein to kallikrein. Then kallikrein acting upon kininogen to release bradykinin. So once these substances are produced, we've talked about the histamines, prostaglandins, leukotrienes binding on the endothelial cells. When these substances bind to endothelial cells, guess what they do? They increase vascular permeability. These cells contract and contract. When they contract, they are increasing in size. When they increase in size, they leave gaps. They leave gaps. So thereby increasing vascular permeability. So when vascular permeability is high, more fluid, all the plasma tends to flow out through the gaps. So as the fluid or the vascular fluid tends to flow out of the gaps, this causes swelling. That's why when you are not, you end up with a little bit of swell. Yeah, your body does swells, and these are the mechanism. Swelling, also known as edema. Then we say the same substance bind to the smooth muscle, receptors on the smooth muscle. The smooth muscle then relax. As they relax, the diameter of the vasculature increases. Then when the diameter of the vasculature increases, more blood tends to flow through the vasculature. Hence you see redness. As more blood flows through the vasculature, when you touch the area, you feel warm. So the area is warm. We also say there are small, there are pain receptors over here. So as the fluid comes out, they compress the pain receptors. When they compress the pain receptors, they get stimulated. When they get stimulated, the net effect is pain. There are bradykinins, remember we said. There are bradykinins. The bradykinins also have a tendency of activating pain receptors. The net effect of that is pain. Sometimes you may get some little bit of fever, and the fever is because in this process there are production of prostaglandins. The prostaglandins can be carried to the temperature regulatory centers that the hypothalamus get activated. The net effect of that is fever. Somebody may ask, why is the increase in blood flow important? Yeah, probably to carry, because remember we have a bacteria here. We need more blood. We need more plasma fluid. The plasma fluid, remember, it contains immune cells. So we want more immune cells to infiltrate the area so that it can fight against the bacteria. Hello guys, thank you for listening. Our next video will be about acute inflammation. Basically, we are going to base on cellular events because what we've been talking about is vascular events. Thank you. Bye bye.